Okay, let's go ahead and take a look at Chapter 13's drill problems and parts of the summary test at the end of the chapter. Chapter 13 is similar to that of Chapter 12. Chapter 12 dealt specifically with lump sum payments, and Chapter 13 will deal with a series of payments. You may want to retire in a certain period of time and be able to get a monthly distribution into your account based upon the amount of money that you put in while you're working. That stream of payments is called an annuity. In Chapter 12, we focused on three separate charts. We had the future value of compounding interest. We had the present value of compounding interest, and then the daily compounding of interest in Chapter 12. In Chapter 13, we're going to use two charts. One is a future value of an annuity called an ordinary annuity chart, and then the second one is a present value of an annuity. There will be some crisscrossing back and forth between Chapters 12 and 13. Let's go ahead and take a look at some of these activities at the end of the chapter, keeping in mind that some of these values are different because of algorithms, whether you're using the Connect ebook or a different version of a textbook with different values. So I'll put the values up here on the screen so that you can kind of keep up with what I'm working with here and be able to calculate it. Okay, number one, the amount, complete the following ordinary annuities for the following using tables in your handbook. Oh, that's one of the tricky things about this particular chapter. If you're in the actual textbook, some of your charts may not have like 1.5%. They may just go 1, 2, 3, 4, 5%. So you won't get the exact corresponding factor in your textbook. So it refers you to the handbook. Now, if you are using the Connect activities, it actually directs you to a comprehensive type of chart. So that could be problematic for you. I wish they would have just put all that together and made it easier. But I'll go ahead and start off with number one, this ordinary annuity. So I'm going to look at the future value of this annuity. I want a $4,500 payment. And I want it to be annually. And I want it to be for 10 years at 3% interest. And I want to calculate what the value of this annuity is if I get $4,500 one time a year for 10 years at 3% interest. So notice that this is a stream of payments that we're making into this investment. Every single year, $4,500 will go into it. So in order to calculate this one, first of all, since it's 10 years, I want to take 10 years times one time a year. That's the number of times it will be compounded. So that's going to give you 10 periods. Okay, and then 3% divided by the number of times it's compounded each year, which is 1, will give us 3%. So I'm going to use 10 periods and 3% on the ordinary annuity chart, which is calculating for the future value of the annuity. So I'll put future value of ordinary annuity. That's a chart that I'm going to be using. So I'm going to take 4,500 and I'm going to multiply that times the coordinating factor between 10 periods and 3% on an ordinary annuity chart. Well, just taking a look at the charts. Here's the future value of an ordinary annuity of $1 per period of interest for a certain number of periods. So if I use that factor or the coordinates of 10 periods and 3%, that's going to take me to 11.4639. That's going to give me the future value of this ordinary annuity of $51,587, and 55 cents. Okay, that's your answer right there. That's the future value of this annuity. If you deposit $4,500 once a year for 10 years at 3% interest, it will generate a future value of $51,587.55. Well, how much did you invest originally? Now, the question doesn't ask this, so this is something that I'm adding on to this particular question. If I know that I deposited $4,500, okay, $4,500, and I did that once a year for 10 years, that's going to give me $45,000. Okay, there's your $45,000. Okay, so all you have to do is subtract $45,000 from your future value, the amount that you actually will receive at the end of that 10-year period of making those contributions, and you actually deposited a total of $45,000, then the difference of those two is your interest amount. Okay, so that would be $6,587.55. That's the amount of interest that you earned over that 10-year period of depositing $4,500 in each year for 10 years, and that generated a future value with your interest of 3%, giving you a total of $51,587.55. Okay, let's go ahead and move on to number 2. Okay, we're going to complete the ordinary annuity, and we have a $12,000 payment that's made twice a year, semi-annually, for 8 years at 7% interest. So at the explanation at the very bottom of this, we have 8 years times the number of times we deposit it in a yearly period of twice, gives us a total of 16 periods, the number of investment periods. We take 7% and divide it by the number of times it's invested each year, which is twice, and we'll use 3.5%. All you got to do is just go to the future value of an annuity chart, find the corresponding factor of 16 periods and 3.5%, and that gives you the factor of 20.9710. Multiply that times 12,000, and the value of that annuity is $251,652. Okay, number 3. Okay, complete the ordinary annuity as an annuity due. So this is based upon the first question that we actually did. First of all, let's go back and look at that first question. So we deposited $4,500 annually 10 times, or once a year for 10 years at 3% interest. And based upon the future value of this ordinary annuity, it became that $45,000 that we deposited became $51,587.55. Each one of those deposits in number 1 were deposited at the end of the year. An annuity due that we're getting ready to do right now is this $4,500 is being made at the beginning of the year, at the beginning of the period. This is based upon a payment that's payable annually, so it's done at the beginning. Remember, number 1's done at the end. So whenever you do an annuity due, D-U-E, then you put it at the beginning of the year. We still use the same chart. And as a result of using that same chart, we're going to earn a different amount of interest, so we have to calculate it accordingly. So therefore, we have 10 years times once a year is 10. With an annuity due, add 1 period, which they did right down here in the explanation. They put in 11 periods, and then 3% divided by once a year still gives you 3%. So they found on that same chart, the future value chart, 11 periods and 3%, and that corresponding factor is 12.8078. Multiply that times 4,500, This gives you a value of $57,635.10, and that is not the answer. If you added one period, which we did, we made it 11 periods, then you must subtract one payment. And there's each one of our payments is $4,500, so we're going to subtract one $4,500 payment. That means the value of this annuity due is $53,135.10. $53,135.10. Okay, so as a result of making the calculation at the beginning of the period versus the end of the period, look how much better it generated a higher interest for you than it did on the ordinary annuity. Okay, let's go ahead and move on down to number 4. Okay, calculate the value of this annuity due without a table. Remember that with annuity dues, you calculate the interest at the beginning of the year. So this is a $2,000 payment that we're making once a year for 3 years at 6% interest. So therefore, 3 years times once a year gives us 3 periods plus 1. We still have to calculate that plus 1 to give us a 4th period, and then subtract it out in the payment at the end. Okay, so I'm going to add that 3 years times once a year gives us 3 periods, plus 1 is 4 periods. 6% divided by once a year gives us 6%. So the first investment, I'm going to take $2,000 plus the interest. 2,000 times 0.06 is going to give us interest of $120. And so that will give us the value of our investment at the end of that first year of $2,120. And then immediately we're going to go ahead and invest that $2,000 at the beginning of next year. And add those two together and find the interest of $4,120 at 6%, which would give us $247.20. Add those two together. So the value of our investment at the end of year 2 is $43.67. Okay, then take $43.67.20 and add the investment at the beginning of year 3 of $2,000. The investment balance going into year 3, add that together, is $6,367.20. Take 6% of that, which will give you $382.03. And the total value of the investment at the end of year 3 is $6,749.23. That's the value of this annuity due. Okay, let's go ahead and take a look at number 5. Okay, we are complete the following using the present value of an ordinary annuity. Notice my language is going to change. It says the amount of annuity expected. It is $900, and its payment is annually. It's for 4 years. And it's the rate is at 6%. Okay, so first thing I'm going to start off with is I'm going to take 4 years times the number of times that it will be compounded, which is once a year, to give us 4 periods. And then I want to take 6% divided by the number of times you compounded in a yearly basis of once equals still 6%. So I'm going to use the present value table, the present value of an annuity, to take it 6% and 4 periods on the present value of an annuity table, which would be this one right here, present value of an ordinary annuity for $1. Okay, so I'm going to find the corresponding factor of 4 periods and 6%. It should be 4.2124. Okay, take that times 900. Takes a corresponding factor of the present value table of 3.4651. And then that would give you $3,118.59. Okay, this is a present value. That's how much we invest today to get a stream of payments of $900 every year for 4 years. Okay, so therefore, if we get $900 a year for 4 years, that's $3,600, right? $900 a year times 4 years, 4 periods, gives us $3,600 a year. Okay, $3,600. So the difference would be your interest. Okay, 3,118 less 3,600. We have interest of $481.41. Okay, so $900 a year, that is what we were paying into it, times 4 years gives us $3,600. And if we invest $31,1859 in order to get that $900 a year for every year, the $3,600, that means we earned interest of $481.41. Let's move on down to the next one, which is number 6. The amount that we expect is $15,000. Okay, we're going to invest this quarterly for 4 years at 8% interest. Okay, first thing we're going to do is take the number of years, which is 4, and multiply that times the number of times it will be compounded, which is quarterly, or 4. That's going to give us 16 periods. Okay, then we're going to take 8% and divide it by the number of times it's compounded each year, which is 4, to give us 2%. Okay, we want to receive $15,000 each quarter for 4 years. What do we invest today to generate $15,000 each quarter for the next 4 years? So we're going to use the present value of an annuity table, and we're going to use 2% at 16 periods in a present value of an annuity table. So we're going to take $15,000 and take it times the corresponding factor of 2% at 6 periods on a present value of an annuity table, which is 13.5777. And that will equal the present value of an annuity, the amount that's invested today, of $203,000, $203,665 and 50 cents. So if we want to get $15,000 every quarter, so that's $60,000 a year for the next 4 years, which is $360,000, right? Is that right? 15,000, 15, 30, 45, 60. So $60,000 a year for the next 4 years. That's $240,000. That's what we're going to get as a result of investing $203,665.50. Okay, let's go ahead and look at the end of chapter problems, the summary practice test. And actually, I'm going to defer immediately to the video that's at the end of chapter 2. to go ahead and play at this particular point. He goes through these very quickly and he explains it really well. So I'm going to go ahead and go immediately to that video.
Ellen graduates from law school. The uncle says, hey, I'll give her a gift, $24,000, or I'll give you $2,400 every quarter for the next 4 years after you graduate law school. That looks like a bribe to me. If the money could be invested at 6... Welcome back. We're in the summary practice test to chapter 13, so here we go. In number 1, Lynn puts in $1,800 at the end of every 6 months for the next 15 years, 8% interest compounded semi. What's the value of Lynn's annuity? Okay, so she's putting it at the end, which tells me that it's an ordinary annuity. We're looking to the future. So in other words here, we're talking 8% semi would be 4%. We're talking twice a year, 15 years would be what, 30 periods? So 4% for 30 periods gives us amount of annuity table of 56.0849. And again, we're not talking about putting $1 in based on this stream. We want to put in what, 1,800? So 1,800 times the table says our money will grow to be $100,952.82. Question number 2. This is the one I get the most emails about. Abby Allen graduates from law school. The uncle says, hey, I'll give her a gift, $24,000, or I'll give you $2,400 every quarter for the next 4 years after you graduate law school. That looks like a bribe to me. If the money could be invested at 6% quarterly, which offer should Abby choose? Now, most people really kind of get confused about this. You're talking about money growing into what? The future? How much money must you put in the bank, what? Today. So you'll have this money in the future? So that would be present value of annuity. That's the way I would attack it. So let me do this first. There are a couple ways of doing it. So you take the rate, 6% divided by quarterly, which is 1.5%. We're talking quarterly, and we're talking, what, 4 years? So that'd be 4 times 4, 16 periods. So it's 1.5%, 16 periods, present value of annuity. The table is 14.1312. Well, in other words, we're talking the stream is going to be $2,400, not $1. So you take 2,400 times the present value of annuity factor, and basically the uncle would have to put in the bank today $33,914.88 to take this stream of money out for Abby. Well, some people don't like to use present value of annuity, so there is another way of doing it. Some people like to use what we call just plain old ordinary annuity, not present value. So you'd go to 1.5% for 16 periods, the old amount of annuity table, and you'd get 17.9323. And then most people do multiply it times each time it's going to be what, 2,400? So 2,400 times 17.9323 gives you 43,037.52. That's where most people stop, and that's where the mistake is made. That means the money's going to grow to 43,000 in the future. But we're talking about today, which is 4 years back in time. You have to go back 4 years to the present value. So you have to go back to find out at 1.5% for 4 periods, which the table factor would be what, 0.7880? And if you multiply the present value times the 43,037, isn't it interesting? You get back to almost the same amount as my present value of annuity. The trick is if you do it the second way, you have to first do what? Go to the future and bring it back to the present. My suggestion to keep it simple, do it my way. Present value of annuity is the easiest way. And number 3, Sanka wants to receive $8,000 each year for 20 years. How much must he invest today? At 4%. Well, so he in fact wants today. How much must he put in today? That's that word today again. So we're talking present value of annuity. We're talking 4%, and because it's annually, and 20 periods. Go to the present value of annuity table, and basically 13.5903 represents $1. In other words, $13.59 would have to be put in today to take a stream back of each dollar. You know, once a year for what, 20 years? But he doesn't want really $1. He wants 8,000. So 8,000 times 13.5903, he basically sunk, or I hate to break the news to you, you have to put in $108,722.40. Question number 4. In 9 years, Rollo will have to repay a loan, $100,000, 6% compounded quarterly. How much must Rollo pay each period? Now, underline the word each period because that indicates what? You got it, sinking fund. So we're talking 6% divided by quarterly, 1.5%. We're talking 9 years quarterly, 36 periods. 1.5%, 36 periods to the sinking fund table, you get 0.0212. But it's not $1 we're talking about. We're talking about we need what, 100,000? So 100,000 times 0.0212 equals $2,120 for each payment. Now keep in mind you could have proved this by looking at what? Amount of annuity at this rate in periods and multiplying it, and it would have come back very closely to the 100,000. In question 5, Lance Industries borrows $130,000. Needs to set up a sinking fund. Here it's telling us at the end of 18 years, 6% interest compounded twice a year. What do you have to pay into the fund each period? That's at each period. So we're talking 6% semi is 3%. 18 years semi is 18 times 2 or 36 periods. So you're going to go 3%, 36 periods sinking fund. You're going to get 0.0158 times 130,000 because you don't want $1, you want 130,000 of them. So in other words, each payment has to be 2,054. And to prove it, you go to amount of annuity table, same rate, same periods. You'll see a table factor of 63.2759. You multiply it times the payment, 2054, and you get very close back to the 130,000, but you're off due to rounding. Question number 6. Joe wants to receive $22,000 each year for the next 22 years, 6% interest compounded each year. How much must he invest? Boy, that sounds like present value to me. He says, what do you have to put in the bank today so you can get $22,000 a year for the next 22 years? So, okay. So we're talking 6% annual is 6%, 22 periods. Go to the 6%, 22 periods for what? Present value of annuity. You see a table factor of 12.0416. Now, what does that really mean? It means if Joe wants to take out $1 once a year for 22 years, that's $22, he only has to put in today $12 and what, 4 cents? But he, in fact, doesn't want to take out just $1. He wants to take out what, 22,000 of them? So 22,000 times 12.0416 says, oh boy, Joe, you got to really, it's going to grow. You got to put in the bank today $264,915.20 today, Joe, if you want to take out $22,000 a year. Twice a year for 15 years, Warren Ford put in $1,700 compounded semi-annually, 6%. What's the value of this annuity due? Annuity due. Annuity due means what? Putting it at the what? Beginning? So we have to add a payment, add a period, and subtract the payment. So we have, in this case, let's see, 15 years, semi would be 30, but add 1 period is 31. 6% divided by semi, or 2, is 3%. We're going to go to amount of annuity table. So at 3%, 31 periods, 50.0027. And we're talking about, he's not putting in $1 each time, he's putting in 1,700. So 1,700 times 50.0027 equals 85,004.59. But remember to subtract the payment. And that's what a lot of students forget to do, is subtract the payment. Gives him 83,304.59. In number 8, Scupper Molly invested $1,800 twice a year for 23 years, compounded semi. What's the value of this annuity due? Annuity due, which means, again, we have to do what? Add a period and subtract the payment. So we're talking 23 years semi is 46, add a period is 47. We got 8% divided by semi is 4%. Look it up under what now? Amount of annuity. 4%, 47 periods is 132.9452. But we're not putting $1 in each time. Scupper Molly's putting in what, 1,800? So 1,800 times the table grows to 239,301.36. Don't forget to subtract one payment, 1,800, gives you 237,501.36. Nelson Collins retires to Canada in 10 years. He's going to deposit, he wants to take out $80,000 a year after 25 years, assuming money's 7% interest compounded. So we're talking interest compounded annually. So 7%, 25 periods. We're going to present value of annuity. What must you put in the bank today so you can get a stream of money out? If you go to 7% for 25 periods, you get 11.6536. Now, what's that really mean? It means that Nelson can do what? He can take out $1 a year for what, the next 25 years, if he puts in $11.65 basically. But he doesn't want to take out $1. He wants to take out what, 80,000? So 80,000 times 11.6536 gives you, oh boy, Nelson, you got to talk about putting in a big hunk of money, $932,000 and $932,288. But keep in mind now, he's going to retire to Canada in what, 10 years? So we need to find the present value. He's not doing anything for 10 years. So we're going to go back to chapter 12. The present value table, we're talking 7% for 10 years annually is 10 periods. Going to 7% for 10 periods, look at the present value table, 0.5083. In other words, when you multiply 932,288 times the present value, look how difference in 10 years makes. Nelson would only have to put in the bank today $473,881.99. If he left it as a lump sum for 10 years, it would grow to $932,288, and then he could begin his retirement. So really you have to do two levels here. Present value of annuity first. Then you have to figure out how many years before he actually retires. In our last problem, Bob Bryan makes a deposit of $10,000 at the end of each quarter, so it's 4 times a year, interest compounded quarterly. After 9 years, Bob says, I've had it, and makes what? No more deposits. What will his account balance be at 4 years after the last deposit? So, first thing is the amount of annuity, because he's putting a stream of money in. We're talking 9 years, quarterly is 36 periods, 8% quarterly is 2%. So 2%, and we're talking 36 periods, going to amount of annuity table, 51.9942. And we're talking, he's not putting $1 in, he's putting in what, 10,000? So 10,000 times 51.9942 equals 519,942. But remember, after this period of time he gives up and doesn't put any more money in, so you have to go to the compound table in chapter 12. We're talking 4 years times quarterly, 16 periods at 2%. So here the compound table says his money will grow with a table factor of 1.3728. In other words, $1 is going to grow to $1.37. But he doesn't have $1 to start. He has how much? 519,942 times the compound table amount. And boy, Bob's money grows, even though he makes no more contributions, 713,776.37. That's why they tell you you should always do what? Plan to put money away early. Even if you can't contribute later on in life, it will still grow through the compounding process.